So we're nearly done filling out our quadrilateral reference sheet. The only thing we need to worry about now is a couple of the extra facts we need to know about proving that a quadrilateral is a parallelogram or a rhombus or a rectangle without actually using the formal definitions. What other ways are there of explaining enough information to prove that something is one of those special quadrilateral types? And we have one example that we did last week. Last week, we showed that if one pair of sides of a quadrilateral are both congruent and parallel, that we were able to prove based on that the other side was also parallel, and therefore it was a parallelogram. We're going to come up with a couple extra reasons in this video. And I'm not going to do the full proof, but I'm going to give you kind of the overview of how it happens. And so that's going to kind of make this video a lot shorter than it could be if we did the formal proofs. So one thing we could use is we could show, if we can show that there are two pairs of congruent sides, that's enough information for us to prove that the quadrilateral has to be a parallelogram. Okay, let's take a look at how that would happen. Okay, so here's a quadrilateral. I have marked here that these two sides are congruent and these two sides are congruent. I also drew in a diagonal. So therefore, we can conclude that that diagonal is common to both of them by the reflexive property. And therefore, those two triangles in that diagram are congruent to each other. Okay, so that's how you would prove that by SSS. We've got these sides that are given and this one by the reflexive property. Now let's take a look. Since we've got these two congruent triangles, that says that this angle right here has to be congruent to this angle up here because of CPCTC. So therefore, this angle is congruent to this angle. But look what we've got there. We've got this mark of Zorro right now. So I can draw a Z from these three lines. And since I know that the two angles that make up this Z are congruent to each other, I can therefore conclude that these two lines, the top and bottom lines, must be parallel to each other. So now I've managed to prove that one pair of sides is both parallel and congruent. And we showed in last week's video that that's enough information to know that we're dealing with a parallelogram. Okay, so those are the steps you would go through in order to prove that you're dealing with you're dealing with a parallelogram. Okay, the second reason is, the third reason down here, the second reason we will cover in this proof is that just like in a parallelogram, the diagonals bisect each other. If we're given that the diagonals bisect each other, that would be enough information, once again, for us to prove that we're dealing with a parallelogram. Okay, let's take a look at what that proof would look like. So here I've got a quadrilateral, and I've indicated here that the diagonals are bisecting each other. These two sides are congruent because they've got one tick mark. These two sides are congruent because they have two tick marks. So that's saying that the diagonals bisect each other. Another thing we know is we know that this angle is congruent to this angle because those are vertical angles. And so that's enough information. We've got three clues about the top triangle and the bottom triangle. And in each one of these cases, we've got two sides and the angle between them. So because of the SAS theorem, side angle side, side angle side, we can conclude that this top and bottom triangle are congruent to each other. Okay, let's see what we can do with that information. So there are basically two things we can do with that information. The first thing we're going to do is, once again, if I look at this angle right here, it's got to be congruent to that angle up there because of CPCTC. So this angle we now know is congruent to this angle because of CPCTC. The other thing we know is that this side here, I'll mark that with a circle, is congruent to this side up here because of CPCTC. So notice, once we know the triangles are congruent, we know that all of the parts have to be congruent to each other. And once again, like we had in the last problem, because of those two angles we just proved are congruent, and because they form this Z shape, we've got the alternate interior angles of those two sides being congruent, or those angles are congruent to each other. So the lines at the top and bottom must be parallel. Remember, I used this little arrow notation to kind of give me the clue that these two lines are pointed in the same direction. So once again, we've got what we had in the last video, or in the last proof, that we've got two pairs of sides of a quadrilateral that are both congruent and parallel. And we showed that that was enough information to know that we're dealing with a parallelogram. So now we know three ways of proving that a quadrilateral is a parallelogram. We either know that one pair of sides are both congruent and parallel, two pairs of sides are congruent. Obviously, if the two sides are parallel, that's the definition of parallelogram, or knowing that the diagonals bisect each other. There's a third way of knowing, our fourth way, and once again, we've got here that the consecutive angles are supplementary. Consecutive angles are supplementary. And once again, like before, that's enough information for us to know that if that's all we know about a quadrilateral, we can conclude that it's a parallelogram. And the reason for that, we don't even need to do a fancy proof about this. That if we know that angle 1 is supplementary to angle 2, if I kind of draw out these lines a little bit, I'm talking about same side interior angles being supplementary to each other. So that lets me know that this side is parallel to this side. And the same thing going on, if angle 1 is supplementary to angle 3, then that lets me know that these sides are parallel to each other. So just from what we know about parallel lines, if we know that the consecutive angles of a quadrilateral are supplementary to each other, that's enough information for us to know that it's a parallelogram. So that winds us up with 4 different reasons, 4 different ways that we could prove that something is a parallelogram, even if we don't know off the top of our head that it has 2 pairs of parallel sides. All right, in the next video, we're gonna wrap up the rectangles and rhombuses and squares in the same way, and that'll complete our quadrilateral reference sheet.